Good morning everyone, this is BremSter, and today I'm coming to you with a puzzle called Perfect Shot by Ridhwan. This is I think this was a recommendation, and it's, I've been interested in 10-line puzzles recently, and when I saw that this was a 10-line puzzle, I really wanted to give a look at this one. Because, yeah, not sure, I was told this one was a little tricky, so again, curious to see how this one goes. Is there anything else to call out? You're all probably aware much of the quads is happening. There's really nothing to call out. The YouTube stuff of please like the video if you enjoy what's going on, subscribe if you're not subscribed, tell people about the content. There's links below to everything else, Discords, to Patreon, which you can join for free, where I try and post updates when I know about them, if people tell me about anything that's going on. Yeah, let's have a look at the puzzle. So, let's have a look at Perfect Shot by Ridhwan. So, normal Sudoku rules apply. So, in every box, in every row, and in every column, the digits 1 to 9 must be placed without repetition. Orange lines, don't think these are Dutch whispers, they're 10 lines. Now, each line consists of one or more contiguous groups of cells, each of which sums to 10. So what that means is you must break the line up into groups that sum to 10. So one or more contiguous groups of cells. So this could be a contiguous group of cells. This could be a contiguous group of cells, and then this could be a separate contiguous group of cells. And if that was the case, then each of those would need to sum to 10. But it might be possible to break that line up in a different way. So for example, it might be possible that those three sum to 10 and then those three sum to 10. That might be a different way of breaking this line up. We don't know, we have to discover how we need to break them up. But we couldn't, for example, have those three sum to 10 and then have those two sum to 10, because here's the important thing, those groups cannot overlap. We cannot share a cell between the contiguous groups. Digits may repeat on lines and even within sums. So, for example, is there anywhere that could happen? Not that I can see here. So I'm not going to be able to give an example of that one, but there may be a way that it could happen, where, for example, if it was possible that these three were a group of 10, it might be possible to go 4, 4, 2. It's not possible on this line, but if that was possible to be a group of 3 that summed to 10, that would be a valid way of doing it. Digits along an arrow must sum to the digit on that arrow circle. So the sum of those two digits goes there, the sum of those two digits go there, the sum of those three digits go there. They're the rules. I'm going to restart the puzzle to restart my timer. Let's give this a shot. So, okay, what do we know about 10 lines? There's only a few ways of breaking up a 10 line. This is a group of 3 cells that sums to 10. Because I can't break it up into 2 and 1, because you can never put 10 into a single cell. So this is 3 cells that sum to 10. They are all part of a 10 sum. This line is one of 2 options. It is either a 1, 2, 3, 4, which I know it's not, or it's 2 groups that sum to 10. And why is that? Well, you can, again, like this, you can never have 3 sum to 10 and then a single cell sum to 10. So, because a single cell can never sum to 10, you've either got 2 options here. I can have 2 cells sum to 10 and have that twice, or I can have all, I can't do 3 and 1, or I can have all 4 cells sum to 10. But this can't be all 4 cells sum to 10, because if this was 1, 2, 3, 4, what would I put on this arrow? The minimum I could put on this arrow would be 5, 6, and that cell there would have to be an 11. So this has to be 2 separate groups of cells summing to 10. Now, we know that any 2 groups of cells that sum to 10 must contain at least 1 low digit. And we know that this arrow must contain at least 1 low digit, as in 19283746. So this, I think, is under some pressure. because the arrow is the same. The arrow must contain at least one low digit, a 1, a 2, a 3, or a 4. Because there must be a 1, 2, 3, 4 in here. There must be a 1, a 2, a 3, or a 4 in here. If there's no 1, 2, 3, 4 here, this sums to 11 again. And there must be 1, 1, 2, 3, 4 at least in those two cells. And I can't use 2. I can't use 2, 1, 2, 3, 4 because there's 1 here, 1 here, 1 here. So there's one cell in there that's 5 or higher. But that doesn't mean that I can't go, for example, 1, 7, 2. Because maybe with that. Now this is a 3 and a 2. Because again, I can't do 2, 2, 1. So this connects with one of the sets of 2. I can't do 4 and 1 because there's only 4 ways of making up a 10 sum. You can do it with 2 cells, 3 cells, or 4 cells. So they've all got to be broken up into sets of 2, 3, or 4. So this has to be 2 and 2 because you can, oh no, this could be 1, 2, 3, 4. Except I'm not sure it can. This is a 6, a 7, 8, or 9. Because the minimum this could be is 1, 2, 3. There's 2 low digits on that arrow. Because a 3-cell arrow must contain 2 digits at least from 1, 2, 3. Because if it doesn't, then the minimum it could be would be 1, 4, 5. Because if I only use 1 digit from 1, 2, 3, the minimum I could use would be 1. Then if I don't use a 2 or a 3, it'd be 1, 4, 5, and this would have to be a 10. So there's 2 digits from 1, 2, or 3 in there. But this could still be 1, 2, 3. Would that be 4, 6, and that be something else? But does that mean this can't be 1, 2, 3, 4? Because I could use 1 digit from 1, 2, 3 in there with the 4 and have 2 digits from 1, 2, 3 in there. And I think I'm still okay. Now this can't be 1, 2, 3, 4. This line is broken. This line, like this line, is broken up into a 2 sum and a 3 sum. This is restricted. It's 5 or higher because these digits here, the minimum they could be, it'd be 1, 2, 3, 4. Right, there is a restriction going on here. The minimum they could be would be 1, 2, 3, 4. And if these were 1, 2, 3, 4, this would have to be 5 because this is these. This is these divided by 2. So basically, double those is that. Sorry, double that is, how do I put this? This times 2 is the sum of those cells. So if these are 1, 2, 3, 4, this is 5. Because, yeah, this sums to this, and this sums to this. So 2 times this is the sum of those cells. So the question would be, how does that work for this cell? If this is 5, how does that work for that cell? There must be. Now, this can't be 1, 2, 3, 4, because then I couldn't make a 10 sum along here at all. So if these were 1, 2, 3, 4, 5, how do I make a single 10 sum along here with 6, 7, 8, 9? I can't do it. So this can't be 5. If this is 6, I don't think this is the way to do this, though. Because if this is 6, these would be 1, 5, and 2, 4. I could do a 3, 7 here. And then what would be left would be 8 and 9. And I wouldn't have the 1 and the 2 to complete them. And there's no way of making a 10 sum. There's no 6 here. Because 6 would use 1, 5, and 2, 4. I could use a 3, 7 over here. But how would I make the rest of the 10 sum? It doesn't work. Now, 7, 8, 9 might give me more freedom. Because if this is 7, these sum to 21. If this is 8, these sum to 24. And if this is 9, these sum to 27. If these sum to 21, the entire row sums to... Hang on, that's a problem. The entire row contains all of the digits from 1 to 9, which means they sum to 45. If you add all of the digits 1 to 9, you get 45. If this is a 7, you've got 7, 14, 21. So these would have to sum to 45 minus 21, which is 24. But that doesn't work because this has to be, because of the 10 line property, this line has to sum to 20 in its entirety, because I could do a minimum of 10 here, and I can't do 10 there and 10 there. So because I can't do 10 in a single cell, this line sums to 20. So if these cells had to come to 24, I'm broken. So this can't be a 7. If this is an 8, these sum to 24. These cells would have to sum to 21. This is a 9. And therefore, this is 27. 45 minus 27 is 18. These cells sum to 18. That's a 2. And these cells sum to 18. If this was 2, 8, those would sum to 10. But those could sum to 8, and then those could sum to 10. But now I've got a 2 here. That's really clever. So is it now playing with this column? Because this is 10, this is 10. So what can this arrow be? Because this entire column sums to 45. This is either 10. If this was all 10, if this was the 10 sum, I'd have 30 and this arrow would need to sum to 15, and that doesn't work because this is this plus this, which is an even total. So if this was 10, 10, 10, and 10, the entire, an even total, because whatever this was is there. So it'd be even, 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 and even, and the entire column would need to sum to an even total. That is the 10 sum. Let's make that purple. That's the 10 sum, and that is the 10 sum. Which is very cool. So these have to sum to 8. They're 1, 7. They can't be 2, 6. They could be 3, 5. So if this was 1, 7, how would I make the 9? Can I do more with that? But I know what this sums to now, do I? Because this, maybe I could figure out what that is, because I've got 10, 20. This is a maximum of 9. So if this is 9, I'm at 29. This is 45 minus 29 is 16. This would be 8. That's if this is 7. If this is 5, this is 27. This would have to be 18. This would be 9. This can't be 1 or 3. So this can't be 5 or 7. So if this is 5, this is 9. If this is 7, this is 8. So if this is 7, 2, this is 8. If this is 7, 2, this is 8, which couldn't be 1, 7 or 2, 6. This would be 3, 5. So if this is 7, 2, 3, 5, 8, how do I make 10? I could do 1, 9. I then couldn't do 2, 8, 3, 7. Oh, it'd be 4, 6. But if this is 2, 5, 9, the 9 could be 1, 8, couldn't be 2, 7, could be 3, 6, couldn't be 4, 5. Hang on. You know what? I'm not sure. But there must be a low digit on here, a low digit on here, and a low digit on here. I get the feeling is this, you know, and I'm not sure how to do it without just casing. There's got to be a way. Is it this? Because a 10 arrow, 2, 3, 5, because these sum to 8 could work if these were 1, 7. Or I put a 1 on this, which means that is... There's either a 1 on this or this is 2, 3, 5. And if there's a 1 on this, that's 3. If this is 2, 3, 5, that's a 1. And that becomes a minimum of 4, 6. That doesn't work. This can't be 2, 3, 5. If this is 2, 3, 5, which is the only value that doesn't have a 1 on it, 2, 3, 5 is the only way you do it. This is 1. 1, 2, 3 is here. And 5 is here. So this is a minimum of 4, 6, 10. This isn't 2, 3, 5. There is a 1 on that 10 sum. That's the 3. This is the 5. So these sum to 7. So I've got 27. So these have to sum to 18. This is the 9. So this could be 1, 8. Can't be 2, 7. Or it could be 3, 6. But this is 1 and then 2 digits that sum to 9. 1, 2, 7 would put the 2 there. 1, it can't be 1, 3, 6. So it's 1, 2, 7. Can't be 1, 3, 6 or 1, 4, 5. So 5, 1, 4. They're the only possibilities as far as I can tell. And there must be a 1 in here. So there's no 1 here, so there's no 8 here. But one of the, where's the 4 in this column? I can't put a 4 on here. So the 4 is down here, and there must be a 4 with a 6. So this is 8, 1. And these are 4, 6, and 3, 7. Now, down here, if this was 1, 2, 7, 1, 2, 3, this again would be a minimum of 4, 4, 5, 9 could work. So if this is 1, 2, 7, this is 4, 5 with 9. If this is 1, 4, 5, this would be a minimum of 2, 6, 8. So this is always 8 or 9. And there must be a 2 or a 4 on that. So it's 2, 4, 5, 6, I think. So is it this now? This can't be a 9 anymore. So there must be a 1 on this arrow, and now there can't be a 1 on this at all. So this can't be 1, 2, 3, 4. This has to be broken up into two. Actually, let's not use blue. Let's use purple there. And let's use a green there. This must be broken up into two 10 sums, because the 9 takes 9 out of there. In fact, there's no 1 there. That's the 1, which puts 1 down here. 1 is down in one of these. Not comfortable with that pencil mark, to be honest. There is a 9 in one of those two. What can this be? Can't be 1, 9. It could be 2, 8. Can't be 3, 7. So it's 2, 8 or 4, 6. This can't be an 8, so this can't be a 2. This can't be a 2, so this can't be an 8. This is 4, 6. So how do I make the 9? One of them is 1, 8, and the other one is 2, 7. Okay, that can't be the 1, so that can't be the 8 because of this 1. If this was 2, 3, this is 4, 6, and that doesn't work. This can't be a 6. If this is a 6, this has to be a 1, 2, 3 arrow. If this is a 1, 2, 3, the only way to make 10 here would be 4, 6, and that would break this. This is not a 6. 2, 4 might work. Okay, so how do I make this 10 sum? It's not 1, 9. It's not 4, 6. It's 2, 8 or 3, 7. These sum to 6 or 7. It's definitely something I'm missing. Okay. It's very clever though, isn't it? Actually, now that I've broken this line up some, what I might want to do is say that, actually, let's use black. That line breaks there, that line breaks there, that line breaks there. Is this the way to do it? Because the colouring is more of a problem for me. Or is the way to do it something like that's a 10 line, that's a 10 line, that's a 10 line, that's a 10 line? What happens if I then get rid of the colouring? Is it clear? Like if I highlight that and get rid of the colouring, no, it's not really, is it? We'll just keep the colouring. I'm just not a fan of too much colouring in the grid. I find it a little disconcerting. I find it breaks scanning. Okay. If this was an 8, this would have to be 2, 6. We should make this 5, 1, 4, 6, 4. If this is 9, couldn't be 1, 8. This would be 2, 7, or 4, 5. Which means these cells are a bit restricted. If this is an 8, this can't be 1, 7 or 3, 5. So it'd be 2, 6. And this would be 5, 1, 4. If this is a 9, there is something going on here, and I can't quite follow it. If this is an 8, not 1, 7, 2, 6, not 3, 5. So this would be 2 and 6, 5, 1, 4. So 8, 1, 1, 2, 3, 4, 5, 6. 7, these are 7 and 9. So we'd end up with 7 and 9. If this is 9, however, 1, 8, if this is 9, hang on, if this was 8, 2, 6, that's 2, 8, 7, I'm not sure, maybe. If this is 9, can't be 1, 8, 2, 7, or 3, 6. Actually, I don't know. This is all feeling a bit weird. If that was, I think I'm looking in the wrong place. So I know these sum to 20, and this sums to a maximum of 18. So the maximum they can sum to is 38. This can't be a 1 or a 2. In fact, there's a polarity thing as well. These are an even total. This has to be odd, and it can't... Right, these are an even total because they sum to 10, 20... They sum to 20. I can't make them sum to 30 because then I need to put 10 into a single cell. This is an even total. So this has to be odd. So it's not 2 or 8, which means this isn't 1 or 7. But beyond that, this can't be a 1, because if this is a 1, these would need to sum to 44. I'd have 21 here, this would need to sum to 24, and that'd have to be a 12. That's the 7. That's the 2. So this is the 8, and this is the 1. That could help. This is 7, this is 27. Those need to sum to 45 minus 27, which is 18. It's got to be 18. 27 plus 8 is 35, plus 10 is 45. This sums to 18. This is the 9. Which means this can't... Actually, it still could be a 1. But 9 now can't go in any of these cells. So 9 is in here. No, 9 is in one of those two, and I can't put 9 on an arrow. That does sum to 9. So these can't be 1, 8, 2, 7, or 4, 5. So 1, 2, 4, 5, 7. This is... And this is what I kind of saw before, that if this was an 8, these were forced, and if these were 9, I thought that was a quintuple, but I was getting a bit locked in on myself. So 1, 2, 3, 4, 5, 6, 7. These are 6 and 8. So if this is an 8, this has to be a 2, because... And if this is a 6, can I make that 1, 3? It's either 1, 3, or 4. And that's not very pleasant, is it? These are also 2, 3, 7, 8. I can't use 1, 9, and I can't use 4, 6. These are also 2, 3, 7, 8. That's a little discombobulating. 6, no, it's not. I was about to say 6 is in one of those two, but that could be a 6. Okay. So, how... I can't put 3 on this line. No, I can. If it's a 3, one of them is a 3-cell 10 sum. If I put 3, I then need 2 digits that sum to 7. And I could do that. Like 163 would work. So that's not the trick here. Okay. So what is it I am missing? Again, it's this line, isn't it? This sums to 20. I know what that cell is. These are the same digit, because this line, this is a 7. That's a 7, that's a 3. Because this sums to 20, that sums to 18. So we've got 38. This is a 7, that's a 3. There's no 3, 7 here. This is a 4, 6. The 7 takes 7 out of there, which takes 2 out of there. The 4, 6. There's no 3 here. So if this was... Why do I have 4 there? Oh, because it could be 6, 4, but it could still be 6, 1, 3. But this is restricted now? Is that 9 restricted? I mean, this has a maximum of 8. It can't be 2, it can't be 3. It can't be 4, because this be 1, 3, which it can't be. 5... 8, 2, 3, 7, 6, 4, 5, 4. 6, 8, 3... Hang on. If this is 8, this is 2, and this is 3, 7. If this is 6, this is 8, and this is 3, 7. This is always 3, 7. So there's no 7 or 2 there. This is 4, 5, making that the 2, which means these have to sum to 8, which means they're 1, 7. Now I can't put 4 in either of those cells. But 5 is in one of those two? 8 is in one of those two. There's 4, 5, 6, or 8. I don't know. This is weird. I get the feeling I can't make this 3, 7, because if it was, it'd be a deadly pattern, but I don't want to use that. There's no 1 or 2 on this. So if this is 7, this would have to be 2, 4, and it can't be. So this is 8, and this has to sum to 7 without using 1 or 2. This is 3, 4. These sum to 8. But the 3, 4 takes 3 out of here. This is 2, 8, and there's the delineation without having to use deadly pattern logic. if this is 6 now, this couldn't be 2, 2. It'd have to be 1, 3. And I still think that's okay. I mean, one of these is a 3-cell sum. Could it be 2, 3, 5? If it was 2, 3, 5, the 9 would be 1, I don't know, maybe 1, 8. It'd have to be 1, 8. So is it about how you would make the sum up? If I use 2, 3, 5, how would I make the 9 sum? This is me using this as a scratch pad. If I used 2, 3, 5 as the 3-cell 10 sum, how would I make the 9? I could use 1, 8. I couldn't use 2, 7, 3, 6, or 4, 5. So it'd be 1, 8. So what's the other 10 sum? I couldn't use 1, 9. I couldn't use 2, 8. I couldn't use 3, 7. It'd be 4, 6. So those would be the way you would make things up. And that seems to work, doesn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9. That does work. So that's not helping me. I mean, maybe it is, but... Oh, this 8 makes that the 2 and that the 8. That puts 2 down here. So this is either 1, 7... or 2, 6, because I must put a 1 or a 2 on this. And this must be the 1 or the 2. But this could be a 3-cell 10 sum. This 8 makes this the 6, which makes this the 4, which makes this the 5, which makes this the 8. The 5 makes that the 4, and that's the 6, of course. The 6 makes that the 8, which makes that the 2. Because I can't do a 2-cell 2 sum. So this is actually the breakdown of that 10 sum, and this 10 sum is made with 3 cells without a 2. So it must have a 1, and then 2 cells that sum to 9, which aren't 1, 8, they're not 2, 7, they could be 3, 6, or 4, 5. And this is the other one. This is 3, 6, or 4, 5. This can't be a 5 anymore, because this can't be 1, 4, or 2, 3. If it was 6, it could still be 2, 4, maybe? Seven couldn't be 1, 6, but it could be 2, 5. This can't be an 8 anymore. So if this is 6, it's 2, 4. And if it's 7, it's 2, 5. This is 2, 4, 5. Because I can't use a 1 on it. 6 can only be 1, 5 or 2, 4. So it'd be 2, 4. And 7 can only be 1, 6, 2, 5 or 3, 4. And I can't put a 1 or a 3 on it. This must have a 2 on it, which means the 2 is up in one of those two. There's no 2 there, so there's no 6 there because of the 2 looking down. That can't be a 2 because this would be 2, 7, and that breaks that. That's a 2. Which means this is not a 2, which means that is a 2, and this is 1, 7. The 1, 7 looks across, making that the 3 and that the 7. Which puts 3 in one of those two. This could be 2, 3, 5. In fact, it has to be, because I can't put an 8 there. Well, it doesn't have to be, but that is a 3-cell sum, because I can't make this a 2-cell sum. So this is a 2-cell sum. It can't be 1, 9, it can't be 2, 8, it can't be 3, 7. That is 4, 6. And these have to sum to 8. They're not 1, 7, they're not 2, 6, they could be 3, 5. 4, 4 doesn't work. This is 3 and 5. This is gorgeous. 1, 2, 3, 4, 6, 9. There's no 6 or 9 in that cell. That's the 4. This is a 6, 9 pair. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a 7. These 1, 2, 3, 4, 5, 6, and 9. The 6, 9 again looks over, making that the 5, and I take 5 out of those. This is cool. I know what these two cells are. They're 1 and 8. Is this resolved yet? No, but these might be. 1, 2, 3, 4, 1 and 5. No. This isn't giving up, is it? Okay. The 9 looks down, making that the 6, which makes that the 9. The 6 looks down, making that the 7. So this is 2, 5, which looks across, making this the 1 and this the 5. The 1 looks back, making that the 8 and that the 1. This is a pair now. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 4 and 6. The 4 looks down, making that the 6, which makes that the 4. Taking the 3, 6 out of there. This is 4, 5. These are 1, 3, 6. The 1 and the 1 look down. I could have done that a while ago, making that the 1. This is the 3, 6, which puts 3 in one of those two. Because where do I put 3 in this column? This is a triple. 1, 2, 3, 4, 5, 6. This is a 7, 8, 9 triple, making that the 3. The 7 makes that the 1 and that the 7. The 4 makes that the 5 and that the 4. This is now down to pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 3 and 5. So these are 1, 2, 3, 4, 5, 6, 1 and 8. Now, if that was an 8, that would have to be a 2. It doesn't work. That's the 1, that's the 8. The 1 makes that the 7 and that the 1. There will be scanning I have missed. There's no 7 or 8 there. That's the 9. I can take the 9 out of those. The 5 looks down, making that the 2 and that the 5. The color is breaking my scanning, and it always does. If you watch other solvers, you'll notice if they keep coloring in the grid, it breaks their scanning too. But there's not much I can do about that for them. And in this puzzle, it's kind of hard to do. The 4 looks up, making this the 6 and this the 4. Actually, I've got these delineations in, so I am going to say this line breaks here, this line breaks here, this line breaks here, this line breaks here, this line breaks here. I haven't figured the other ones yet, but I can turn off all of that. I still need to figure out this line. But these, this could still be a 4 cell sum, 1, 3 with 2, 4. In fact, I know there's a 2 on this. In fact, that is 2. Where do I put 2 in this column? There has to be a 2 in one of those two. That 2 looks across saying not there. That's a 2. So if this was 1, 5, 2, that would be, what is it? That would be 8, and that would have to be a 2. It doesn't work. This is 1, 3, 2, which is only 6. And that can't be a 10 sum on its own. That has to be a 4, and that breaks the line there. That's cool. So these sum to 10. They have to be 3, 7, because I must use a low digit and I don't have 1, 2, or 4 available. That's 3, that's 7. That's beautiful. The 3 makes that the 5. These are 1, 2, 3, 4, 5, and 9. The 9 looks up, making that the 5 and that the 9, which looks down, making that the 6 and that the 9. The 4 looks down, making that the 3 and that the 4. The 7 looks down, making that the 8 and that the 7. The 6 looks down, making that the 3 and that the 6. The 4 looks across, making that the 6 and that the 4. And the 9 says, that's not the 9, that's the 9. So 1, 2, 3, 4, 5, 6. And that is the solution to the puzzle. That was huge amounts of fun. I had to use math, I had to use geometry, I had to use all sorts of tricks, and it was great, great fun. Yeah, I love this puzzle. Perfect shot, it really was. That was really, really good stuff. I love 10-line puzzles. I want to do more of them. Thank you everyone for watching. I hope you enjoyed this one. That's half as much as I did. Actually, I hope you enjoyed it more than half as much as I did. I hope you enjoyed this a lot more than that. I hope you enjoyed this 20 times as much as I did. But if you enjoyed it half as much as I did, you had a great, great time. Thanks everyone for watching, and as always, good luck with your solving.